Hi, we're Team Colite, and we have developed a web application that we're very excited to share with you today. Introducing our team consists of Simon Benzer, Matthew Hayward, Kandana Narla, Kaylin King, and Andrew Denman, and we will just jump right in.
Hi, I am Matthew Hayward and I'm a software engineer on this application, and I will be summarizing the problems at hand. So currently, Colite Technologies is a company that's based in Columbia, South Carolina that offers energy and lighting solutions that leverage the latest technology to provide reliable and long-lasting alternatives to their customers. So despite being a growing company, the main problem that Colite currently has is that they have no way to read from their polls and visualize their data in real time. So as a result of the wide array of services that they currently offer, they work with an immense amount of data that is taken from each of their many poles. This data can cover anything from voltage inputs to the longitude and latitudes of each of their poles. And the company handles this issue by manually creating tables in Excel in order to create data visualizations. Now, obviously, this is a very tedious process that puts clients in Colite in a position where they have to create their own visualizations in order to see the impact that switching to renewable energy has had on their business.
Hey y'all, my name is Kandana Narla, and I'm one of the software engineers that worked on this web application, and I will be covering app goals and the technologies that were used. So as for app goals, the main problem that our application solves is allowing Colite Technologies to be able to visualize, alter, import, and export data visualizations that users create. They will also be able to view their respective polls on a Google Maps API that should illustrate the data more effectively. And finally, we have also been tasked with adding warning flags in the event that any of the polls exceed a given threshold. For the purpose of security, Colite only wanted 4 accounts created that would have access to the raw data for data visualizations. And so this addresses several pain points. It addresses the pain point of Colite having to manually create their data visualizations, and it also addresses the pain point of security because there is a limited number of people who would be given access to the limited logins, and therefore that would make the source of a data breach easily pinpointed in the event that something like that would happen. Moving on to technologies used, so we can break that down into the front end and the back end. The front end of the app was built predominantly on Vue, which lent itself pretty well to general use of JavaScript tools. The graph renderings on the data visualization page were built using chart.js. The map page was built using Google Cloud Platform, as visualizing the polls requires the use of a Google Maps API, specifically a Google Maps API key. And we also used Amazon QuickSight, which was tricky once we initially switched from a hard-coded application to a fully deployed application, but once we got the hang of it, it was definitely easy to use. The only outstanding issue that we had with AWS is that we do have to manually deploy the application every time that we had to make changes to it, which is a tedious process considering the number of changes that the application has undergone throughout this process. For the backend, we used Elastic Beanstalk, which is an Amazon Web Services tool used to make deploying web applications easier. We used Amazon Web Services at the request of our client, and in addition to Beanstalk, we also utilized AWS's relational database S3 and EC3 tools to store the client's raw data, and we used MySQL to connect to the database and manipulate the raw data as needed.
The first page that you'll be faced with when loading onto the application is the home page. There's a Colite logo in the top left corner to show users that they're on a Colite Technologies app, as well as a navigation bar where they can change around to different links throughout the site. The links on the navigation bar are the home page, data visualization page, list of parts, map, graphs, about us, and contact us. We also have a section explaining just what the features provided by this application are, as well as how it is done. We have a link to the GitHub repository so users can view the source code for the application. And we also outline 3 main features that we feel are the most important to the application. The first of this is the visualize polls on Google Maps feature. This is incredibly important to Colite, and Kudana will go into later on, but basically you're able to click different polls and view the attributes associated with them. In addition to that feature, we also have the create your own graphs, which will be used for data visualizations. You're able to select a MAC address, a graph type, the data you wish to visualize, as well as how many points you wish to visualize of that data. And the last page that we include on the home page, and another important feature, is the list of parts page. So Simon will talk more about this, but basically you're able to set the MAC address and view different attributes that belong to that MAC address, aka the poll. In addition, we have a link to the About Us page and the Contact Us page that we feel are very important to creating a use of familiarity with the users.
My name is Kalen King, and this is the homepage of the Colite data visualization app. And this also links us to the About Us page, where you can see more information about the main purpose of the application, as to how it's supposed to be used, and where you can contact us if you wanted to have something changed on the app, which would be over here. And this contact us page has all of our information, including our emails.
Now, if a user wants to navigate from the homepage to the data visualization page, they will first be faced with a login screen. This login screen has two forms and a forgot your password button. The reason why there is no sign up is so that Colite is only able to give out the usernames or create accounts for people through Amazon Web Services, but they want to really ensure security so that no one can break in and view their actual data. After signing in, you're able to navigate back to the original web page through any of the above navbar links, as well as logging out. In addition, the users can create any type of visualization they want by using an Excel file or any other sort of data, such as a MySQL database. Now, after navigating back to the original homepage, I will hand it over to Simon to tell us more about the list of parts page.
Hello, my name is Simon Benzer, and I'm the team lead and one of the software engineers on this project for Colite Technologies. So, the most central part of this project is accessing live data from poles, whether it's a streetlight or a solar panel. And the problem we set out to solve was, how can we access that data live and visualize it? Well, the first thing we need to do is access that data. So we had a SQL database that stored that data. Now we have our web app that needs to access it. So if Dr. Ansalchi, who's our client, wanted to access that data and visualize it, first off, at its most central level, you would go to where the API is hosted, right here, and then they would go api.polls. And now you can see the data at this time of every single poll that we need to access. So this right here is one poll. ID 10, poll ID 6, that's the MAC address, or the MAC address for that current poll. So now what you need to do is, we need something to access this data and to do something with it, which is what we set up in Vue. So if you go to our list of parts page, the client can now access the data for every single one of these polls organized by MAC address. So click on, let's say, MAC address 11, and we wanted to figure out what the battery output is. Go here, and max battery limit right here is 12. Now, if we wanted to see the location of the MAC address at, let's say, 18, we would click 18 over here, we'd scroll down, and we could see the longitude and latitude. So it's very easily visualized. And what this does is, now we have a central part that all the other aspects of our app can access. So the map, the graphs, data visualization, everything now has a central part that they're all accessing from. And what this allowed us to do was to branch off and to accomplish everything else we needed to do. Thank you for your time. Again, my name is Simon Benzer. I'm the team lead on this project.
Hello, my name is Andrew Denman, and I will be showing you the data visualization page here on our website. This is the graphs page, as you can see. On this page, you can select the polls you want to display, and then select the data you would like to display. As you can see, this is a mostly binary data, with 12, 11, and 10 being the only inputs. We can also go over to the other type of data that is much more, it's continuous data instead of quantitative data. You can also select which type you would like to see, with bars being especially good if you want to pick out a particular data point. Say if there's like an outlier or something, it's easy to see then. You can also select the scatter plot, which automatically has a line of best fit built in, and you can see with this data, it's each individual data point, just another way to look at it. The line of best fit is used, as well as the number of data points. You can see that the by lowering the number there and updating that there's only 10 display data, and the line of best fit is very sloped in the positive, showing that it's getting worse over time, or better depending on which data you're looking at. We can also see the locations. This page isn't very useful as we have the maps page. Yeah, if we go back here, the data visualization is based on chart.js, and it connects to the SQL server via MySQL, which I will show you now. Here's my insert statement I use to just put a new data point in the table. You can see the ID on this is 19. There's no 19 on the pull list page. So I can show you a live fresh data point put in. If we reload the page, you can see that 19 is now on the list, and if we display it, you'll see there's just one data point, which is to be expected, as I only added one data point to the server, but many can be added to each individual poll. Thank you very much.
If you navigate from the homepage to the map page, you will be able to see all of the polls that we have right now. We only inputted latitude and longitude information for about 15 of the polls, just for ease of visibility at the moment. But if you select each of the markers, you can see that all of the information regarding that poll is displayed. And because the markers draw their data directly from the API, which is connected to the database, the markers do add and update in live time. So if you were to manipulate the data in the database, the map would update accordingly. And that is about it for the map page. Moving on.
Hello again. My name is Simon Penzer, and I'm going to describe to you the test page. If our client needs to figure out if the information that they're showing in the list of parts page is actually correct, they go to the test page. Like the list of parts page, it will give you the information that you need. However, unlike the list of parts page, you can actually see if the information is correct or not. Like it says up here, if it shows up a dark green right here, then it will be passing. If it shows up a dark red, then it'll be failing. As you can see, none of these are actually failing. However, if I wanted to actually make sure that it's correct, I would look for the MAC address 15, and I would pick the parameter. So let's pick over voltage comeback right here. So I'm going to go to the API right here, find the poll ID 15, and then find over voltage comeback, which is 14.448.12.552. 14.448.12.552. So I know that's working correctly. Thank you very much.
Thank you so much for your time. We had a pleasure explaining our app to you and its capabilities. Thank you so much.
Thank you.
Thank you.
Thank you.